In the last section, we talked about measures of central tendency. Those are all about where the middle or center of the data is. In 3.2, we talk about measures of variation. Measures of variation are sometimes called measures of dispersion. They describe how variable, in other words, how dispersed or spread out the data is. We will consider three types of measures of variation. First is the range. Range is the difference between the largest and smallest data values. So you compute it by going largest value minus smallest value. For example, find the range of the observed values 13, 4, 8, 4, 12, and 5. The largest is the 13, and the smallest is either one of these 4s. So the range is 13 minus 4, which is 9. Next, we'll turn to standard deviation. Standard deviation is quite a bit more complicated, and I want to start out by giving you sort of a conceptual idea of what it's all about. So let's consider the population data set 1, 3, 5, 6, 7, and 8. And the idea is we would like to know on average how far these data values are from their mean. So let's compute the mean first. It said this was a population, so I'm going to use mu for the mean, not x bar. And of course we get the mean by adding up the data values. And dividing by the number of data values. There's 6 data values, so we'll divide by 6, and we get 5. Let's make sort of a diagram so we can see how these data values look. I need numbers from 1 to 8 on my number line. And as we said, the mean is 5. Then I'm going to make a dot for every data value I have. We're interested in how far the data values are from the mean 5. 6 is 1 unit away. 7 is 2 units away. 8 is 1, 2, 3 units away. 5 itself is 0 units away. It's right at itself. On the other side, 3 is 2 units away, and the 1 is 4 units away from the mean. 1, 2, 3, 4 units. Now what we wanted was the average of those distances. Deviation, by the way, is another word for distance. So the average deviation will be the sum of all the deviations or distances. I'm just going to work from left to right across my diagram. 4 plus 2 plus 0. Then we had a data value 1 unit away from the mean, 2 units, and 3 units. That's a total of 6 distances, so I divide by 6. That gives me 12 divided by 6, which is 2. So the average distance of the data values from the mean is 2 units for this particular data set. That tells us something about how spread out the data is, which is the goal with standard deviation. Now, for technical reasons we will not cover, the above method is not actually used. Instead, what is used is a formula that gives a similar measure of how much the data values deviate or differ from the mean on average. That said, this is a useful conceptualization to keep in mind as we work with the more complicated standard deviation formula, which we'll start with in the next video.